All right, everyone, buckle up because today we're tackling something I know a lot of us have a bit of a love-hate relationship with, multiplication tables.
Ah, yes, the good old times tables. The source of joy and frustration for students everywhere.
You know it. So get this. We got this excerpt from a book sent in by a listener, and let me tell you, it claims to have unlocked the secrets to mastering multiplication.
Secrets, huh? Sounds intriguing. What's the angle?
Well, it's not about those brute force memorization tactics we all suffered through.
Oh, thank goodness. Nobody wants to go back to those
Right.
days.
This book is all about multiplication algorithms.
Yeah.
Essentially, it says there are hidden patterns within the times tables that once you see them, make it all click into place.
Okay, I'm listening. I've definitely seen some patterns, especially with the easier ones.
Totally. Like multiplying by 0, 1, and 10.
Yeah, those are pretty intuitive. And even 11 has that cool repeating digit thing.
Exactly. But hold on to your hats, folks, because this book claims those patterns are just the tip of the iceberg.
It does. Okay, now I'm really curious.
Get this. It claims there are similar patterns for all the other multiplication tables, even the ones that feel like, climbing Mount Everest.
Now that's a bold claim. I'm a bit skeptical, gotta be honest. I mean, some of those tables are just brutal.
Same here. I remember those time tests back in elementary school.
Hmm,
Not fun. But hey, maybe we were going about it all wrong this whole time.
maybe. There are definitely patterns in mathematics everywhere you look, if you know where to find them. Like, take the Fibonacci sequence, for example.
Oh yeah, that's a cool one.
Right, each number is the sum of the two before it.
Seems random at first.
Exactly, but it follows this elegant underlying pattern, or the golden ratio, that pops up everywhere in nature and art and architecture. It's all about these underlying structures, these recurring relationships.
That's fascinating. So are you saying it's not totally crazy to think there could be hidden patterns in multiplication tables too?
I wouldn't say it's impossible. The question is whether these patterns are practical and easy enough for people to actually use to help them learn.
Okay, I can get behind that. So listeners, think back to your own experiences learning multiplication. Was it all flashcards and time tests? Or did any of you stumble upon any shortcuts or tricks that made it easier?
Yeah, I'd love to hear from our listeners on that, because one thing this excerpt really emphasizes is moving away from rote memorization, which, let's be honest, most of us went through. And there's actually a lot of research showing that understanding the why behind math concepts leads to deeper learning and better retention.
Like once you get it, you really get it.
Precisely. So even if these so-called multiplication algorithms aren't some magical solution, the idea of exploring patterns and relationships within multiplication is definitely valuable. It could change how we approach learning and teaching math.
All right, so let's dive into some specifics. What kind of patterns does the excerpt actually suggest?
Well, they use the 9 times table as their main example.
Oh, the 9 times table. Everyone remembers that one.
Right. So they point out that if you look at the products from 1 by 9 to 10 by 9, you'll notice a couple things.
Okay, let's see. 1 times 9 is 9, 2 times 9 is 18, 3 times 9 is 27.
Exactly. So first, did you notice that the digits in each answer always add up to 9?
Wait, really? Oh, wow, you're right. 9, 1 plus 8 is 9, 2 plus 7 is 9. That's wild.
It is. And second, the tens digit increases by 1, while the units digit decreases by 1 each time.
Wow, I never noticed that before. Okay, that's pretty cool. So instead of just memorizing, say, 9 times 6, I could think, okay, it has to be a number that adds up to 9 and follows that tens units pattern.
Exactly.
Wow, that's actually really helpful. But does this kind of thing work for all the tables?
That's the big question. And the excerpt does acknowledge that some patterns are more complex than others. But their argument is that by focusing on these kinds of relationships, we move beyond just rote learning, and we start to engage with math on a much deeper, more meaningful level.
Makes sense to me.
Like you said it yourself, remember that aha moment when you finally understood how to carry numbers in addition? It wasn't just memorizing a rule, it was suddenly understanding the logic behind it.
Yeah, it's like a light bulb went off.
Exactly. And this book seems to be arguing that we can have those kinds of aha moments with multiplication too.
Okay, so while we can't say for sure if every claim in this book is going to hold up under scrutiny, the whole idea of multiplication algorithms definitely has me thinking. It's exciting to consider that there might be these hidden patterns out there just waiting to be discovered.
It challenges us to look beyond the traditional methods and really appreciate the power of patterns in math.
Who knows, maybe there's a hidden math genius in all of us just waiting to decode the times tables in a whole new way. And hey, if you've got any cool tricks or insights about the times tables, we want to hear them. Share your thoughts with us because here at the Deep Dive, we're all about curiosity and exploring new ideas. Thanks for joining us in this deep dive.
Until next time.